Welcome back to Minds Matter, a podcast sponsored by the Monash Centre for Consciousness and Contemplative Studies. I'm Beth.
And I'm Ava. And on Minds Matter, we explore research from neuroscience and psychology while occasionally talking through our own personal experiences.
And this week on the podcast, I spoke to Nadine Dijkstra, who is a senior research fellow at the Wellcome Centre for Human Neuroimaging at UCL in London. We spoke about her research on mental imagery or imagination and how that informs or relates to our perception, and how we're able to tell the difference between what is reality, so out in the world, and what's our imagination, if both of these processes work together. It's super cool and interesting. I hope you guys enjoy it.
My name is Nadine Dijkstra, and I'm a senior research fellow at University College London. My research focuses on mental imagery in general, so kind of generating pictures in your mind, seeing with your mind's eye, and then specifically how that works in the brain, and also how our brain is able to tell apart imagination from reality.
Your research looks at how we can tell the difference between imagination and reality. And can you explain why that's an important question? Because I think that we would think, oh, well, isn't that obvious for us what we imagine and what we don't? So can you explain why this is an important question?
Yeah. So there's two parts to this answer. First of all, it's important for disease like schizophrenia or other types of mental illnesses where people get psychosis or hallucinations. Clearly, then it breaks down for people. They're not able to tell apart imagination and reality anymore. So like doing research onto this is important to help those people. But also just for healthy people, we also often confuse reality and imagination. So we might think we're good at it, but actually, it breaks down every night for us when we dream. So that's one example. Lots of people sometimes hear things or see things that aren't there. It's another example. And kind of the way that we think about how we see the world currently, so perception, the way that contemporary neuroscience thinks about it is that part of that is also imagined. So we kind of fill in what we see based on what we think and what we expect and based on our experience with the world. So the line between imagination and reality is just not as clear as we like to think.
Within this line of research, there's two different processes called top-down processing and bottom-up. Can you explain what those are, what the difference is, and why this is important for our perception and our imagination?
Yeah, that's a great question. And that directly related to what I just said about the perception bit. So basically the way that people now think about perception is that it's a combination of bottom-up and top-down processing. Now, what this means is bottom-up is things that directly come into your senses. So light waves into your eyes when we talk about seeing, or, sound waves into your ears when you talk about hearing. So that's kind of the input into the camera of your brain, basically. And then the top-down bit is how the brain processes that based on what we already know about the world, based on our experiences, based on our expectations. So the brain does something with these signals to process it in a way that's relevant and useful for us, for our current goals, for how we see the world. So that means that always everything that we experience is not just what's out there in the world, but it's always tainted or colored by our top-down processes, by what we already know and what we, expect, what we want, and all of those things. Yeah.
So does this mean that two people could see the same thing differently and not just interpret differently, but physically see something differently based on past experience or?
Yes, 100%.
Okay. So an important study within this field is research on the Perky effect. Can you explain what the Perky effect is?
Yeah, of course. So this is a study from 1910. So that's more than 100 years ago. It's really cool. I came across this when during pandemic times I was bored and I couldn't do any experiments. So I just started reading old papers. So it's a study that's done by Mary Choose West Perky. So that's important to note because when you look at the study, the Mary bit is cut off and it's just Choose West Perky as the author. So I think it's really cool to mention that this was a woman who did this study. Basically what she did is she asked participants to come to the lab and then asked them to imagine the several objects at a certain location on the wall. So for example, an apple. So they had to imagine seeing an apple at a certain location on the wall and then describe what they were experiencing. So they would say something like, oh yeah, I see this round thing and it's kind of reddish. But then at the same time, without the participants knowing, she had this projection machine hidden away in the lab. And she was projecting the same shapes at exactly the same location. So she would project, for example, a red circle at exactly the same location, at very faint kind of intensities. And then she checked what happened. And what happened was that people thought that what they were seeing was imagined. So they were like, whoa, my imagination is so vivid. I didn't know I could do this. This is so cool. So they really thought that what she was projecting was a direct consequence of their own imagination. So that's a confusing reality for imagination.
So someone would look at an object and think that's what they imagined because they were primed to imagine that beforehand.
No, they were imagining it at the same time. So they were imagining
at the same time,
at the same time projecting these things. And then they thought that the projection was from their imagination, not from the real world. Yeah.
And why would this happen? How could this get confused?
So basically, so this is the kind of what my PhD thesis was about, looking at what the brain does when we imagine and see things. And the brain does something very, very similar. So that's probably the reason. When we imagine a red apple, like very similar brain areas become activated as when we would actually see that apple. So the same system is used for imagining and for perceiving. In that sense, those signals are intermixed. So it makes sense that they are confused. That comes back, I think, to the thing that I talked about with the top-down processing. Part of seeing is imagining.
So when people are seeing, it's also based on these other things that they're bringing into it. Yeah, that's
exactly. It's also an active kind of filling in process.
So one of the really important concepts that Nadine mentions is this idea of top-down processing versus bottom-up processing. So Beth, as our more neuro-computational person, I was wondering if you could tell me and the audience a little bit more about what that means and in which cases those types of processes would be more important.
Yeah, cool. So I think when we listening to Nadina's work, it may be confusing how top-down and bottom-up process relates to what she's doing. And I'll just try and paint a picture. So hopefully it's easier to understand how those things relate. So when Nadina speaks about mental imagery or imagination, so that's what's going on in our head and there's no perception involved. You could sit here and you could close your eyes and you could imagine a tree or something. So that would just be mental imagery. When you're doing that, there's no bottom-up processing involved. And there's no bottom-up processing because nothing from the outside world is coming in and informing that mental image. The only thing that's informing that mental image is top down. So stuff that is already in our mind or in our brain that's forming that. So nothing bottom up from the world is capturing that. When Nadina speaks about mental imagery and imagination, you can think of that being a process that involves no bottom up processing, only top down processing.
So how far can we kind of go with both of these types of processes? Because it seems like from what Nadina was saying, we get these things confused pretty easily. So when as you're saying, when we're imagining, we're basically going top down, meaning that we're saying, I'm going to picture this apple, and then things happen in the brain that kind of allow you to almost feel like you're seeing that apple, but you're not getting the actual sensory input that you would need to have that more bottom-up response. If we were only to have one type of processing, so if we were only to have only top-down processing, how would that influence the brain? And then if we were only to do bottom-up processing, I think that's what it feels like we think we perceive the world in. We're taking things in, and then from exactly what we see, that's what our mental imagery forms from. But it sounds like all of those things are always working together. So could we just have one type of processing, or why would we not just have this bottom up instead of top down?
So I'm no expert, so I'm just going to answer this in what I think is right. With the bottom-up processing, from what I understand, if we just had bottom-up processing, so that's just what we get information from the world, so I look around and just what is hitting my eyes, if we only had that, I think, and Nadina mentions this too, the brain couldn't process that. It would be so much to process all the time in terms of computational load. What we were experiencing just only came from what was hitting our eyes. It would be too much computationally. And the other thing is, and Nadina mentions that, if our visual system just acted in this way and we didn't have any top down, so what's happening in our brain influencing what we're perceiving, we wouldn't have things like attention and these kind of things that are really important when we navigate our way around in the world. Another nice example of top-down processing, which I think we can all relate to, is when we're writing an email, and if there's spelling mistakes that we've written, we never, you don't see them. That's the whole thing with spelling mistakes and grammar errors. And you can read something. You probably all would have done this. You write a paper and you read it 10 times and there's still a spelling mistake and you don't see that. And that's an example of top-down processing, because even though we're reading it and we have the bottom up, so the words on the page coming to our eyes, at the same time, we have what our mind thinks is there because we've written it. We have all this context for it. So we just don't see that.
So top-down processing, is that also what is responsible for some visual illusions that we might see? So those types of illusions where your brain is just filling in the blanks, and that's just to help us be more efficient in our processing?
All visual illusions, things like that. You guys probably have all done that. There's a cool example where there's a checkered board. So there's white and black. They're all meant to be the same. Well, they are the same color. But on the checkered board, there's this green structure, cylinder thing that we perceive as casting a shadow on the checkered board. The top-down processing fills in what we think should be there. And it's really hard for us to see the checkered board as the colors that actually it is, because our top-down processing is like, no, there's a shadow there, so it has to be these different colors. So that's just one example of one of those visual illusions, but there's a lot. That's when this top-down processing, that's a good example of when it comes into play.
I think actually I've just pulled up some of these illusions, and I think it is a really good example of kind of understanding this, both this idea of top-down and bottom-up processing, but also when Nadine was talking about her research being about separating imagination from what's really happening. It's one of those questions where you think it's actually usually so obvious to you, and we're rarely ever having issues with that. But then when you see these visual illusions, they're so strong that it's okay, there's definitely something happening here, because I'm looking at this checkerboard and I'm sure that this is a different color. And it's just crazy that your brain is able to fill in the blanks in that way. And I think also getting to some of the research that she talked about, like the Perky experiment that she mentioned, that older experiment, I think it's interesting to see how powerful your brain is and how much that top down can actually constrain the bottom up, to the point where if you're fully in that experiment seeing something being projected onto the wall, but your head is telling you it's impossible that is being projected because of these situational constraints, that it's the 1900s and there's no real projectors. This is not something that you feel could actually be possible. So the only way that your brain is able to explain it to itself is that, wow, my imagination is so strong, even though you're actually seeing something, but that we're really easily able to trick ourselves with these kind of top-down processes. I think these visual illusions feel like they're a good illustration of that, because they're very intense experiences. And I think it's a case in which you can kind of understand that, oh, maybe sometimes these things that we think are real, or maybe on the other hand that we think are not real, we can really actually easily be tricked.
And what's crazy about the visual illusions is even when you know they're there, you still,
I know.
So even though you're aware of, okay, this is an illusion, this shouldn't be this, it's still your brain. So it's like, no, sorry. Like that's, we're going to say
I'm looking at the checkerboard one with we'll put this on in our show notes and on the Instagram, but I'm looking at the comparison of the one where the illusion is kind of disappears because it creates just a line between all of the same colors, and it doesn't look like the same image. My brain is still saying that's not, can't be that. So yeah, I guess I understand this question with these visual illusions. I understand this question of how does your brain actually distinguish between these things more, because it is maybe not as obvious as it feels subjectively.
Yeah, and I think initially, with Nadina's work, it feels on first thought, well, why is this a question we need to answer? Why do we need to answer how we distinguish between imagination and reality? Isn't that really obvious? Don't we know what the difference is? And then when you get to these examples and you start thinking about it, it's like, wait, no, like we don't really know clearly what the difference is in a lot of these cases, which is pretty crazy.
Yeah, it's disturbing. Another What is Reality episode.
So you have a lot of amazing work, but focusing on your 2021 paper to test how our mental imagery, so our imagination, affects our perception. So similar kind of to looking at what they were doing in that Perky effect experiment. Can you explain the experiments that you ran and how you designed that study?
Yeah, so we wanted to look at, kind of do it in a modern way, what Perky did. Basically standardize it, lots of trials, lots of participants, good stats, because she just had like a couple of trials, a handful of people, and it was all very descriptive. So we wanted to double down on that. And what we did is we asked people to detect ratings, which are these lines, very boring, simple pictures, basically, but they're easy to work with. And we presented them in kind of TV static. So people had to say, oh yeah, there's some lines in the TV static. Now there are, now there aren't, blah, blah, different trials. And then at the same time, we asked them to imagine these lines, either the same lines or different lines. And then we wanted to see what happens. So, if people are imagining the same lines, are they less likely that they see real lines? Because they might be like, oh, well, these lines are imagined, so I'm not seeing them. Or are they going to be confusing their imagination for reality and thinking that, when they're imagining lines, they are more often likely to say that they see a line. So that was basically what we wanted to test.
Yeah. And what did you find? What were the results of that study?
Yeah, so we found evidence for the latter. It's kind of the opposite of what Perky found. So instead of reality being confused for imagination, we found that imagination was confused for or mistaken for reality. When people were imagining these lines, they acted as if these lines were really presented. They were like, yeah, I see it. It's presented, even though they were only imagining it.
And what would be one of the reasons that maybe you found a difference to the other study?
Yeah, so there's a couple of reasons that we've been thinking about since then. One of them is the multi-trial nature of our experiment, which sounds a bit technical, but basically what it means is that once participants know that there's a stimulus that might be presented on the screen, they're going to look for it, right? So in Perky's setup, they didn't even know that there was a projection lantern. They had no idea something could be presented to them. Whereas in our setup, the whole task was to say whether something was presented or not. So that could be one factor. And that factor is also the reason that we did the 2023 study to check if that was the case.
That's the next thing we want to talk about. Your 2023 paper, you looked at how we separate our imagination from reality. And one of the first questions is, why was this hard to test in the past? And how did you make an experiment that you were able to test this?
Yes, it's related to what I just already kind of hinted at. Is Perky's experiment is genius because people have no idea that something could be presented to them. They really don't expect that. It might mean that makes it easier for them to think that it's imagined. But the problem with that is that you have low statistical power. It's very hard to say that this is a real effect and not just some fluke. In science, we want to have repetition so that we can say, oh, this is really a lawful thing. And it's not just by accident that we observe it. We want to have people unable to know that there's something presented to them, but at the same time, you want to have loads and loads of data. So if you do multiple trials in one participant, and once they notice that something's presented to them once, then you can throw away all the other trials, basically, right? Because then they know that something could be presented to them. We came up with a solution by doing an online one-trial psychophysics study, is what we call it. Basically, we did the exact setup where people have to imagine gratings now. So we don't tell them about showing any gratings. We just ask them to imagine them. And then secretly on the last trial, we present the grating to them. So there's only one trial and we don't tell them about this. We just say, imagine a grating, tell us how vivid your imagination is, and then do that a number of times in a row. And then only on the last trial, we actually show a grating. And then we ask, hey, on the last trial, was something presented or not? We can only do this once. But then because it's online, we just send it to hundreds and hundreds of people and I get enough data that way. So that's the way we went about that.
One of the things you were looking at for this paper was these different models of how imagination and perception are either separate, not separate, how they all work. And you found evidence for a model that and tell me if I'm getting this wrong, is that our imagination and perception are not separate and they combine together to form our experience.
Basically, the idea is it's kind of based on what I mentioned before, that when you imagine, you use the same system as when you perceive. So when you imagine and perceive the same thing at the same time, you can't separate them at all. It's just one signal, basically. And then we think that the way that you decide whether something is real or not is whether this combined signal is strong enough. So if for some reason your imagination is really, really strong, it's going to be indistinguishable from your perception of reality because it's the same system thrown together. There's no tag in the brain saying this is imagined and this is real, basically.
But when we're perceiving something in reality, so just say I'm looking at the apple, the signal of that would be really strong. Whereas if I'm imagining it, the signal wouldn't be as strong. Yeah.
Yes,
okay.
generally, yes. Usually because of the way brain. Yeah, so we can get into the neurophysiological details for that reason. A big part of that is because the most strong excitatory neurons are located in the middle layer of the primary visual cortex. And that's where signals come in from the retina. That's the bottom-up signals.
Yeah.
So those bottom-up signals lead to strong firing rates in your visual system. Whereas the top-down signals, that's what you use when you imagine, they mostly activate the outer layers, and these outer layers mostly house modulatory neurons. So that means that if you only have top-down signals, which is the case during imagination, then you're mostly modulating existing firing rates, which means that the total amplitude is going to be lower than when you get stuff also coming into your eyes. But because the brain is a noisy system, it is possible to happen that for some reason those top-down signals do get really strong. But it's a noisy system. There's loads of interaction. Things can kind of go wrong or cross a threshold or something like that. But in general, because of the way the brain is wired, imagination is going to be less strong. Yeah.
And then, so when we're dreaming, it would just be the top-down signals when we're dreaming, but that can feel real. Or
I know, yeah. No, not for sure. So this, as is always the case, when you have a beautiful theory, then there's some case, and you're like, wow, okay. This is one of those cases where you don't have any bottom-up input, but you still feel like something is real. So there's two possible explanations, three actually. Maybe for some reason those top-down signals do get strong enough. Maybe there's a problem with neurotransmitters so that the inhibition excitation balance is off and just blow up, which could be possible, just because of some chemical imbalance. Another thing is that during dreaming, you could get input from your lateral geniculate nucleus. There could be some waves going through. That's not the retina, but it's a station between the retina and the visual cortex. So that could still drive activation in the middle layers of your primary visual cortex, potentially. Very speculative. And then the other option is you have the amplitude of your signal, but you also have the reality threshold. So for some people, you might need less strong signals for things to feel real. And for other people, you might need stronger signals. And one thing that's possible is that maybe when you're dreaming, your reality threshold decreases. So you need less strong signals for it to feel real. So even though the strength of the signals remains the same, whether or not it feels real, that kind of criterion or the threshold, that changes.
I was also interested in the way that Nadine has looked into this neurally. So there's a point at which she talks about this idea of there being different types of connections between different regions in the brain that are responsible for different things. So I understood what she was saying as when there's these bottom-up signals, when you're actually taking sensory perception in, there is firing that goes on in the visual system. And that's why we have these stronger, obviously we're seeing things that much more clearly than if they're just top down, because things are being taken in from the retina, but we have these stronger effects. But then that when it's top down, when you're imagining things, different neurons within the visual cortex are activated. So it's more, she talked about these outer layers, and she talked about modulatory neurons in the outer layers. So basically the modulatory neurons are neurons where this idea of a station between different parts of the brain. So is it this idea that things start in the visual, normally bottom up, things will start in the visual cortex, you get activation there, and then that's feeding into what you'll ultimately interpret as what you're seeing. But then when you're imagining something, it skips that bottom layer, but you still are activating another part that's an intermediary part that then also allows like imagery to be created once you're trying to interpret what your brain is doing. It's a place where you're getting a certain message, and that message is saying, oh, there's a red blob that I'm seeing. And then you take, and that information gets then passed on to the higher order regions that will interpret what that red blob could be, taking in contextual information and stuff, and then says, oh, you're seeing an apple. But then if you're just imagining the apple, because there are connections going from all of these different regions in the brain back and forth to each other, there's still almost that relay message of there is something that looks like a red blob, but you're just not getting all of the sensory input, so it's not as strong of a projection.
Yeah. So you don't have that same activation level when you don't have the bottom-up processing. When you're just imagining something and you don't have any of the input coming into your eyes, then none of the neurons are firing it's in the middle layer of the primary visual cortex. So they're not activated. So just think about it, when you don't have that information, there's a whole bunch of neurons that are just not firing. They're not doing anything because they don't have that information. When it sends a signal for the imagination, it's not as strong than if you're perceiving something as well, because it doesn't combine together. It's like, oh, all these neurons are firing. This is what we're perceiving, and that's what makes it not as strong. But there are examples that we speak about where even if you don't have the bottom-up processing, if the firing rate or the strength of the signal from the imagination is strong enough, it does cross over and it does become more real.
Yeah, I thought it was really interesting how there were kind of those two components of what I guess the brain makes up as reality, of this strength of those signals, but then also that second part of like the threshold at which we say, okay, that's real or that's not real.
With this reality threshold, I was wondering if it's the same for everyone or if that threshold is different for everyone. But I guess that not only is it maybe not different for people, it might change within a person. Is that true?
Definitely, yeah. I mean, I really think so. So even context might change it. So that's something that, could maybe explain the fact that we find slightly different results than Perky. In Perky's context, the reality threshold was very, very high, right? People were not used to things being projected on walls. It was 1910. There were no computers. There were no projectors that were used in general society. These were these very niche things. People, they didn't even know there was a projector. The probability that something was real on that wall was very, very low. So that threshold was very, very high, probably, for those people.
Does that mean our reality threshold? I guess initially I assumed it was just, I didn't think of it being formed by context so much, but yeah, I guess it makes sense that it would be. So our reality threshold would change throughout history then, I suppose, as our environment and what we're used to.
I'm also not sure, but that's one of the speculations that we have about why we find something different to Perky. So one of the participants also said in Perky's study, you have these anecdotes. It's lovely what people said when they were doing this. And one of them said, if I hadn't known I was imagining, I would have thought it was real. It does feel real, but they just can't fathom that it could be real, basically, which is kind of the hinting to, for me, kind of makes me think, oh yeah, maybe they, their threshold was just so high. I think the context is important. Historical context might be, one of the contexts, but maybe also, if you're in a foggy road late at night, then, you might think things are more likely to be real because your signals are lower in general. So, and it's, if you're driving, it's very important if you see things that suddenly appear. So you might interpret lower signals as being real than when you're, broad daylight, just driving around. So all of those things probably have an influence on our reality threshold. And then you mentioned differences between people. I also think that's probably a big thing as well. And that's something that we're interested in exploring more. For example, whether people with psychosis have lower reality thresholds. That's one of the things that we want to look at. Yeah.
What are the benefits of having this reality threshold? Wouldn't it be better for the brain just to go, okay, this is the external world, this is reality. Why have we evolved to do this top-down processing where we fill in blanks?
I think there's a lot of reasons. So one of them is that bottom-up input is often ambiguous. So, for example, you can have the same exact input into your eyes represent different things. If you have a circle or like a rectangle. And then depending on the depth, it's going to be exactly the same input to your retina, but it is actually a different object. So you need to kind of take into account the context to make sense of what that actually is. And taking into account the context is already top-down processing. And another example, driving on your foggy road and you suddenly see something quick move, you're probably going to think that's a deer, when you're in North America. And that's very useful to know, right? You don't think that's a human suddenly crossing the road, even though your retinal input is ambiguous and you couldn't just guess it based on what's coming into your eyes. So those are just dealing with the fact that input is noisy is a very, very important reason why you want to use top-down processes. But also it's more efficient because you're going to pay more attention to things that are relevant for you and you're going to ignore things that are irrelevant for you, which is just, the brain has limited capacity. So you need to make things work efficiently. So this means that, things that are important to you, like food and all of those things, are going to be noticeable sooner than things that are less important to you, even though, again, the input is just light waves. So there's no importance added to light waves. You need to interpret that in line with your goals. Yeah.
And with this reality threshold, do we think that it's just something that humans have, or do we think non-human animals have a reality threshold as well?
Oh, that's a really good question. I hadn't thought about that. Probably like primates and stuff. Yes, I would think. So it's really hard to study imagination in non-human animals because you want to ask them if they're doing it. So, and because it's only happening in their heads, right? Without being able to ask them, it's hard to know. There's some evidence that lots of animals can do something like working memory, where they keep something in mind and then use it later on. So, for example, you show them a picture and then you let them do something else and then you ask them to report something about the picture that they saw. That's kind of supposes that they are able to keep this picture in mind. But then the question is, do they see it in their mind or is it stored somewhere? Do they have an experience with that or not? It's very hard to test. I would think that, given that lots of animals have top-down, I think most animals have a top-down kind of system, you would need some way to keep those signals apart.
One of your findings from this paper that we're talking about, it was that people who had more vivid imagery had more reality monitoring failures. So what would be an example of vivid imagery? Because I think that that's interesting. And do we know what sorts of people might have more vivid imagery?
So vivid imagery is really it's a problematic concept, I think, in general. In imagery research, people are arguing about it a lot these days. And I think that's really good because, what it means is quite ambiguous. I think how most people interpret it is about the clarity and the amount of detail that you see in your mental image. So if you picture an apple, can you see the contours? Can you see the different shades of red? Can you see the reflection? Can you see the whole apple at once, or do you see like a bit of parts kind of flickering in and out? And how much does it look like actually seeing an apple? That's, I guess, what vividness means. And then your second question was about what sorts of people have more vivid imagery. Yeah. So that's really a big question. It's really hard to answer because it seems to be that the research kind of gives all kinds of contradictory results with that. There's people who aren't able to generate any mental images. It's called aphantasia. So when you ask them to count sheep, they don't see anything in their mind. It's just like an idea, but it's nothing visual, nothing you would describe as visual. And these people have no issues in their daily life whatsoever. There's lots of studies trying to figure out how this affects people. And it doesn't seem to matter that much whether you can see things in your mind or not. So there's a few small things. So for some reason, it seems to be related to prosopagnosia. So that's face blindness. Having very unvivid imagery makes you a bit worse at recognizing faces for some reason, which is interesting. Another thing is episodic memory. Remembering things that happen to you seems to be lower when you have less vivid imagery. So when you have more vivid imagery, you seem to have more kind of episodic memories. Those are a few things. But other than that, there's nothing very, very clear at this point, which is it just depends on itself.
Yeah. Because I was wondering if people like artists would have more vivid imagery, and then if they have more reality monitoring failures. I was just wondering if people have if that would be the case, because you would think that they would have more vivid imagery given what they produce, but I'm not sure if that is.
So that's really I love that question, and so it's not my field, so I haven't looked in it in a lot of detail. But what I know about it is that that's what everybody thought, but it doesn't seem to be the case, because there seems to be the case that lots of people with aphantasia or lots of artists have aphantasia. They actually can't
wow.
imagine. I think you can do art in many different ways. And I think one thing that somebody with aphantasia was describing about their art is they don't have like a ready-made picture in their mind before they start, but they develop it as they go. You get constant feedback, right? For example, when you're painting, you do see it. When you have a brushstroke, you see it and then you can adjust it and you can do art again in many different ways. And I think that's kind of the thing that I really like about the imagery research is it really shows you can do lots of cognitive tasks in many, many different ways. Imagery might be one way for some people in some things, but you can do it in many different ways. And like art I think is a great example. Yeah.
And I suppose whatever you personally do, it's hard to imagine doing something differently. So I have a very vivid imagery. So I just assumed I could not imagine creating anything without that mental image. So the idea that artists could do that, I just can't. That doesn't seem possible to me, but I guess everyone comes at the problem with whatever they do.
I think so too. So there's a really funny paper, I think it's about a decade ago. There was this big imagery debate. Maybe you've heard of it. It's the 70s all to the early 2000s where people, when you imagine something, is it more like language? Is it more like a symbol? Or is it like a picture? So the depictivism versus symbolism debate. And then there was this paper that showed that whether or what people believed, whether it was symbolic or depictive, was directly correlated to their imagery vividness. So the researchers themselves, the one that were like, yeah, it's depictive, they just have very vivid imagery. And the people who were like, no, it's symbolic. They're just the imagery was just not vivid. Yeah.
It's hard to imagine doing it in a way that you don't do it. Yeah, that's really
exactly. I mean, I think this is a really great example that, this balance between top-down and bottom-up processing between reality and evidence in the outside world and our own kind of perceptions and experiences, it does also pertain to science and scientists. We also bring our top-down kind of bias into our science.
I guess what I thought initially when I read this, maybe there would be a reality threshold that's quote-unquote optimal functioning, and then maybe there'll be a reality threshold that's not, but it sounds a bit more murky.
But what is optimal functioning? What is optimal functioning for who? So I love using this example, but there's some cultures where people with schizophrenia are perceived as shamans because they hear things that aren't there, and they have a religious function in this society. And within this society, their reality threshold is optimal for functioning in this society. They are treated very well. They have a happy, fulfilling life. They're part of the community. They have connections, all of those things. So then what does it mean to have an optimal reality? And so I think that's a really good example that, everything is relative and it just really depends on your system and your environment and those things. Yeah.
And so it's okay if you don't have an answer to this, but if your research was to find a clear people with schizophrenia, would there be a way to explore interventions by changing someone's reality threshold? Would that be a possible avenue of research? Is that as a way of treatment?
Yeah, I think that might be a way of going about that. So the way I think about it now is that probably the reality threshold is more a consequence than a cause of something like schizophrenia. Mm-hmm. So I would think that makes sense. So it's
that makes
probably something goes wrong earlier on, like in belief systems, and then because of that, they start interpreting things as more real. So, targeting that might alleviate some of the symptoms, but I wouldn't think that's a treatment. But again, I think exploring how this whole mechanism works is just really, really important to get any treatment. Like it is clearly a part of it.
I think the listeners would be interested. Is some of the work that you do, and it might not be, are you also informed by, do you read philosophy? Does that all also contribute to your work? But is that also what you incorporate when you're working out what experiments you want to plan and your ideas and things?
No, it's a really good question. And I do engage with philosophers in my work. I don't think about designing experiments per se, but more about conceptual thinking. This idea of a reality threshold, I mean, not directly, but the idea that imagery and perception only differ in intensity was first thought of by David Hume in 1739 in his A Treatise on Human Nature. So he there wrote the whole thing about how imagination only differs in, that's a really nice quote, something like the imagination of red that we form in the dark only differs in degrees of intensity from the perception of red that strikes our eyes in sunshine. So yeah, really like imagination and reality only different intensity. It's kind of what he said. I was just, doing my stuff. And then one of my colleagues, Jorge Morales, who is an experimental psychologist and also a philosopher, he was like, hey, you're proving you. I was like, oh, that's that's nice. So yeah, really cool, right? So yes, and there's a very active imagination philosophy kind of field, which I also try to engage with. For example, this idea of vividness, the concept of vividness is something that psychologists are just like, yeah, we know what it means. And then philosophers are like, hey, wait a minute, do you actually know what it is? So those, I do think that's very important.
One of the things that I thought would be very helpful for me in understanding this model is if we could kind of synthesize what the model is.
So let's go over this model so we understand what's going on, because it's kind of crazy what's going on. All right, so we have imagination. So that's our mental imagery. And that, as we've been speaking about, that's our top-down process. So we have that going on in our brain, and there's brain areas that are activated when we have this imagination top-down process. So that's one thing that's going on that determines our experience. Another thing that determines our experience is our perception. So what we're seeing right now, what I see when I look around the room. And studies have shown, and this has been kind of known for a bit now, that when we're perceiving a red apple, the same brain areas are activated as when we're imagining it. So that same area in the brain is like, okay, there's a red apple. But this is when we're perceiving it, that's our bottom-up processing. So that's what's coming from the environment. Initially, one of the questions was, okay, well, if the same brain areas are activated when I'm imagining a red apple and I'm perceiving a red apple, how do I tell the difference? How do I know when I'm imagining, and how do I know when it's reality in front of me? And this was one of the big questions. And there was different ideas about how we could maybe be doing this. And what Nadine's work has shown is that we do this by a thing called a reality threshold, which is kind of cool. So what a reality threshold does is it takes information that we have from our bottom-up processing, so that's information that's out in the world, and it takes this information. And then it also takes information that we have from our imagination, so our mental imagery of the apple. So it takes information from that too. I'm doing stuff with my hands, but you guys won't be able to see. So we have information coming from outside the world, and then we have information coming from inside our mind. And those two things combine. So we've got all of the information, and then we have something called a reality threshold. So a threshold is just a level that we need to reach. So we have a level that we need to reach, that when our brain says that's reality, that's not reality. So when this information combines, it goes against this threshold, which is a level, and it goes, okay, is there enough information to say that this is real or not? So let's do the example if you're just imagining a red apple and it's not outside in the world. We would get that information, and it would go to our reality threshold, and it would go, okay, does this level reach, is this in reality? And in most cases, I'm not saying in all, because we've got cases like dreaming, people are really different cases, but just say in one example, it goes, no, you know what, that's not enough information for this to be reality. So I know it's not real. I know it's my imagination. But then just say you have the example where you're looking at a real red apple. You have that information from the outside world coming in. You have your top-down processing about context, about all these other things, and all that information combines. And in most cases, again, it would be, okay, that's enough information to pass the threshold. So that is reality. So that's how we distinguish between those two things. And what's interesting about this is how our reality threshold changes. So we speak about this. So when, a really good example is we're dreaming, it feels like all the things are passing reality threshold, but we're not getting any information from we're not getting any input into our eyes when we're dreaming. When people are hallucinating, so when something isn't really there in the outside world, but it's clearly crossing this reality threshold because the mind is saying it is there. That's another example. So when we're thinking about dreaming and hallucinating, these are kind of, I guess, obvious cases. But then what's also interesting is we have other cases that aren't so obvious, like these visual illusions that we use in our everyday life. Or Nadine gives the example of when we're driving in a foggy road and we see a movement out the corner of our eye. So we have the information coming in, so that's our bottom up, and then we have our top down processes, and it's like, okay, well, it's a foggy road, there could be animals out, and also I need to stay safe. That's another thing that the top down processing is saying, like, I need to be safe. So in that instance, even though in terms of our visual information, it may not be super clear that that should pass a reality threshold, given our top-down processing, and in that instance, how it's important because of the context and the safety and these kind of things, then that does say, okay, it passes a reality threshold. I'm going to behave and act as if that is an animal, even though in that instance, the visual information wasn't as clear.
One last thought that I had about it, and this isn't a scientifically formed thought, but when I was thinking about which cases telling reality apart from imagination is difficult is in memory, because there's so much evidence that some of people's like strongest memories are not how they happened. So I think we've talked before on the podcast about these so-called flashbulb memories that are memories for like really emotional events, and where people feel like they remember so clearly all of these like sensory inputs, kind of like what we're talking about, of like as if there was really strong bottom-up processing. And there was one study in particular that had people right after 9/11 happened, they had them write down where they were, exactly how they found out, really in detail. And then like 10 or 20 years later, they had those same people come back in and write down where they were and how they found out and stuff like that. And for most people, they had like completely different stories from like that didn't correspond to how they'd actually found out or where they were when they found out, even though all of them reported that those memories were extremely vivid and were extremely sure of how those things happened. And so it feels like there's some kind of link that I haven't fully figured out in terms of sharing this thought, but between some of these processes and this consolidation that might happen in memory, this like change that might happen in memory, where somehow things in the reality threshold maybe get swapped out and get changed, but we really feel like those things are 100% what happened. And people will have like arguments with their siblings or something about specifically how something happened when they were kids, and they'll have completely different versions of it. And one person will vividly remember them being the person who did whatever action it was, and someone else will remember their sibling or them having been the actor in that situation. So it feels like there's something there, and I don't know if Nadina has done any research on it, but where reality seems to get mixed with imagination, or just some part of the brain is more suggestible when it comes to thinking about things that happened before.
Yeah, I think that's really interesting because, again, this is just a thought, but I would think if the reality threshold is changing, probably one thing that could influence that is how emotionally salient something is. So I think we can all relate to when we're in a situation and it's more highly emotional for whatever reason, it does feel like we have way more top-down processing, interpreting what's going on, and it's very much that situation. I mean, I feel like I've been in situations that have been very emotional, and I said, it doesn't feel like reality. I feel like everyone who knows me has probably been there for some of those too. So I think it definitely could be, if people are remembering a traumatic event like 9/11, probably in those moments there. And I don't know how that would all work, that the reality threshold is changing, but I feel like it does feel like when traumatic things happen or highly emotional things happen, our brain interprets things also in the moment differently. And also, if you think about it, when you're in a really traumatic event, your attention has to be focused on survival. You're just totally focusing on one individual thing, whatever that is. Think of the example when you're driving down the foggy road and you think that the thing moving in the side is an animal because for survival. When you're in something really serious, that is even heightened. So it probably warps lots of things we think are reality in those situations.
Yeah, that's a good point, that there's probably something different maybe happening at encoding that then messes up how people are retrieving that information. But I think also what you said about this idea that there's a lot of top-down processing when you're trying to deal with something that maybe was highly emotional. And I think there's a lot of research at this point that shows that, you know, obviously, as we're talking about, like, our memories are pretty unreliable. And one thing that your memory really serves to do is to tell you who you are and what you think has happened to you. And sometimes maybe in those stories of what happened in 9/11, maybe the changes that people kind of make to their stories then fit better with how they see the arc of their lives working and like the kind of narrative of what happened in their lives. So maybe it is kind of a mega top-down thing happening where you have these things encoded, but then maybe there's another process or something that's happening but not consciously that's massaging the way that your memory works so that it's better integrated into kind of the arc that you might have of your life. So maybe it's also really comes down to this top-down, but for a different process, maybe a more complex process. I'm not sure, but that's cool to think about.
I think the takeaway is reality is confusing.
That definitely, I think definitely whenever we get into the neuro stuff, there's a lot of things that we take for granted are extremely complex. And both of us have been studying psych and neuroscience for a lot of years at this point, and it never ceases to amaze me the types of things that people will study that when you hear about what they're studying, you're like, that's extremely important, but I never even would have thought about it because it's something that I took so for granted. But then it's actually everywhere.
Yeah. Because initially when I was reading on this topic, I thought, oh no, I have a really vivid imagination. Does that mean I understand reality less? That's initially what I thought. But then it could just be my reality threshold maybe higher. I don't know.
Do you think it's higher or do you think it's lower?
Because I don't feel like my imagination is becoming my reality. I feel like I have very vivid mental imagery, but I feel like I know that that's still, even though it's very vivid, I feel like I know it's my imagination. But then after this, I was like, I don't know, do I know? Because that's why I was asking also the question about the artists, because I was wondering, are these people who are really creative and can come up with things in their mind, do they have more reality monitoring failure? And that's why I was wondering if people who are more creative and have these vivid imaginations and can come up with like different worlds and whatever, do they have more reality monitoring failures?
Yeah, that's interesting, because I think if you were to, if you're rendering something, I'm thinking of someone who's writing maybe a sci-fi book where they have to do a lot of world building, then maybe in that way your imagination has to be really sharp because then you're bringing it out kind of onto the page. But I think there's also a chicken and the egg situation where is your imagination really vivid? Is it that you're able to almost trick your brain into thinking that you're seeing something super clearly because you're rendering it super clearly in your head? Or does your brain think that it's rendered clearly, but it's actually not really clear? You know what I'm saying?
Yeah, I see. Yeah, so it actually is, the imagination isn't that vivid. We just think
but you're like, oh, that's good.
Yeah.
Because I often think that sometimes when I don't know if this has ever happened to you, but sometimes I'll be confused about whether or not something happened in a dream or actually happened. It's not that I have a vivid memory for it. It's just that I'm like, did that happen? And it's kind of plausible, but it's really fuzzy, but I'm just not sure like where to sort it. But if I were to bucket it into the real part, then I think, again, my brain might fill in the gaps and make it more vivid in that sense. So I think there's like maybe two things happening, but I don't know how you would get at which is which. I'm sure a neuroscientist, maybe Nadine, will be like, this is how you would test that, obviously.
Yes.
But to me, it feels like there could be like both of those things happening where your brain could be tricking itself in either way, if that makes sense.
Yeah, I see what you mean. Yeah, metacognition, I guess.
Yeah, exactly. Yeah. Well, clearly this one has got us thinking in loops, so I don't know if it's good or bad. But thanks for being on the journey with us.
Is there anything else new you're working on or excited about that you want to share with us?
Yeah, so two things I'm really excited about. So one, Steve Fleming, who's the professor, who is the co-author on this paper. He's been super influential in my work, and his work is on metacognition, so how we think about our own thinking. Whereas my background is more about, visual neuroscience. How does this all work in the visual system? And I'm kind of keen to explore this other area a bit more. What goes into making this reality decision? How do we reflect on these things? And where in the brain is that implemented? And could we play around with that in some way? So that's one bit where I'm really keen on exploring that more. Also, how this reality threshold is implemented. That's probably some kind of, monitoring that's going on somewhere in the brain that's monitoring these visual or sensory signals, say, oh, it's strong enough or it's not strong enough. So how does that kind of monitoring work? And another thing that I'm really, really excited about is making imagination feel real using brain stimulation. So it's all still very, very new and maybe kind of out there. But my thought would be that if it's really intensity, then we could just change the intensity by stimulating, so there's techniques like TMS or TDCS where you can change the electrical current in the brain it's non-invasive, so there's no kind of long-term effects. I'd be keen to play around with whether we could use that to make people's imagination kind of feel more real in that way.
Can you just explain a bit more how TMS, how that works?
So TMS, it's transcranial magnetic stimulation, and basically it uses a magnetic field to alter the magnetic field that comes from the neurons that are firing in your brain. So when neurons are firing, you get electrical signals and they create a magnetic field, and then the TMS system can hijack that magnetic field to alter the currents in the brain. That's how it works. And it's just like a hairdryer kind of thing that you can hold over your skull.
Okay, cool. So then if you could increase those imagination signals, then it might seem more real for people.
It's also very possible that it just doesn't work at all. So it's really something we need to
put it in. And then back to the metacognition, is the idea that if we have some awareness of this reality threshold, or if there is some monitoring with our metacognition of it, we could have more control over it. Is that maybe one of the ideas?
Maybe, yeah. So in the first instance, we think that setting this reality threshold or the implementation of this reality threshold already is metacognition, because it's already that there's a sensory signal that's evaluated. You can already kind of interpret that as something, and then something else is pointing at it, basically, which is already metacognition. And that could all be kind of unconscious and automatic. And then the next step is indeed, like, to what extent are people aware of this? Which we just have a paper out, preprint out, where it seems people are not really aware of this, that, they're not really aware that they confuse their imagination for reality or anything like that. It just kind of happens, which makes sense. Yeah. Whether people would be able to influence it, I don't know. I mean, that's an empirical question. It would be interesting to check. But my intuition is no. My intuition is that it's very ingrained and automatic.
Our intro and outro music is Nobody Stayed for the DJ by Glacio. Our transition music is Back for More, also by Glacio. Minds Matter is mixed, edited, and created by Beth Fisher, she's the Australian one, and me, Ava Madasuza. We'll be back in 2 weeks with a brand new episode of Minds Matter. In the meantime, find all our episodes and show notes on mindsmatterpodcast.com.